talk about it. Okay, you have triangle RTG. If we increase the measure of angle T, what will happen to R and G? They'll decrease. Why will they decrease? I heard 180 somewhere. Okay, if your sum of your interior angles is 180 degrees, if I increase one, then the other two sum have to decrease. Okay, so the measure of angle R or the measure of angle G, or maybe both, will decrease. Okay, if we decrease the measure of angle T, what will happen on R and G? They will increase. So either both of them or one of them will increase. Okay, if we increase the length of side GT, what effect will this have on the other side? It will increase. Okay, and if we decrease the side of GT, what will happen to the other side? Decrease. Awesome. Questions on 1 through 4? Okay, take one of your triangles. Okay, label your angles 1, 2, and 3. Okay, you can take a straight edge, or if you can see through your paper, you might be able to draw a straight line. Okay, so we know that the interior angles of a triangle add up to what? 180. So now I just want you guys to see the proof behind it. So if you take your triangle and rip off each of your angles, okay, if you put all of your angles on this straight line that you drew, it should fit perfectly and add up to what? 180 degrees, because the three interior angles will be, so what do we call that? Supplementary. So do you see how they all fit and form that angle? It's kind of hard to mess with small pieces, but is everybody's angles forming a straight line? Okay, cool. So that is the proof behind the fact that the sum of the interior angles is 180 degrees. So you can write that here. The sum, oops, can't spell, of the interior angles of a triangle is 180 degrees. Okay, so that is what we call the triangle sum theorem. Okay, so in good old chapter 6, when we incorporate proofs, and if you're ever trying to deal with something in the regards of the interior angles adding up to 180, your reason would be triangle sum theorem. Questions on that? Okay. You can put those pieces, please don't let them go on the floor, just put it to the side. We're done with that triangle. Okay. So, based on your observation about interior angles of a triangle, complete this statement. The acute angles of a right triangle would be blank. What do you think goes there? So the acute angles of a right triangle, this is how many degrees? 90. which means these two added together have to equal 90. So those two angles would be not necessarily 45 and 45, because you could have 30 and 60. What do we call that? Complementary. Remember, complementary angles add up to 90. Supplementary angles add up to 180. Very good. Okay, so we're going to practice a little bit with the triangle sum theorem. So if angle A is 53 degrees and C is 88 degrees, somebody tell me what ATC would be. What would ATC be? 39 degrees. Okay, so all you're doing is subtracting from 180 to find that missing side. Okay, for number 2, how would we solve this? 90 plus 2x plus equals. What would have been another way to solve that? Pardon? What'd you guys say? What would be another way to set? Very good. 2x plus 3x equals 90. And when you solve this equation, you end up getting to that step, but you can start there automatically. Why? Very good, because they are complementary angles. So your acute angles of a right triangle are complementary. So you have 5x equals 90. So what does x equal? 18. Questions on 1 or 2? Okay, next one. Grab your second triangle. Label your angles in the order that they have them. So 1 at the top, 2 here, 3 here. Okay, we're just going to use the straight line that they have here. Okay, now we are going to prove what we call the exterior angle theorem. So if we wanted to know the angle measure of angle 4, we could do so by adding together angles 1 and 2. So to prove this, rip off angle 1, rip off angle 2. Okay, put angle 3 on the line. Okay, and then angles 1 and 2 would make up what? Angle 4. Okay, do you guys see that? So the exterior angle is equal to the sum of the opposite two interior angles. So not the one that's adjacent to it, the two that are opposite of it, so not touching it. Okay, so your exterior angle, which was angle 4, is equal to the sum of the opposite two angles. So do we add 3? No, because 3 is adjacent to the exterior angle. We want the ones that don't touch it. Okay, so you can put that to the side. Again, please don't put all the pieces on the floor. The measure of angle 4 equals the sum of angle 1 and angle 2. So again, it's not the one that's adjacent, it's the two that do not touch the exterior angle. Okay, how would I solve number 1? $140 is equal to what? 140 equals 2x plus 5x. So 140 equals 7x. So what does x equal? 20. What's the measure of angle SLH? What's the measure of angle SLH?
45.
Third time's the charm. What's the measure of angle SLH? 40. How'd you get 40? 2 times 20, because we found x is 20, so you're just substituting in. Okay, what would be the measure of angle LSH? 100. And notice how the sum of those two angles is equal to our exterior angle. That's how you can check to make sure you've done it right. Okay, so the sum of these two has to equal the exterior angle. Okay, let's look at number 2. 3x minus 10 equals what? 2x minus 10 plus 45. Okay, I'm going to combine like terms on each side. 3x minus 10 equals 2x plus 35. Subtract 2x. I get x minus 10 equals 35. So what does x equal? 45. Okay, what does the measure of angle SLH equal? 80? Okay, what about the measure of LSH? 45? Oh, duh. What about the measure of LHW? LHW? 125. Do you see how the sum of 80 and 45 equals our exterior angle? Very good. Okay, so they might trick you and add in an x or a 3x or something crazy, who knows. Okay, just to see if you'll add maybe these two together or these two together. Remember, it is not the one that is adjacent to the exterior angle. You take the other two, farthest away. Okay? Questions on the exterior angle theorem? Pretty simple. Okay. Alright, a little bit of definitions from our textbook, so we're going to write them word for word. Look at me, I'm the one dropping my angles on the floor. Okay. Triangle sum theorem states the sum of the measures of the interior angles of a triangle is 180 degrees. Exterior angle says the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior, that just means non-adjacent, the remote interior angles of the triangle. What does remote interior mean? Non-adjacent angles. Very good. Okay, so those are fancy definitions that might pop up on like a matching or multiple choice or something for these two theorems. Questions? Awesome. Okay, let's see. In order to do this next part, somebody in your little area needs to get a couple straight edges for everybody. So, because you're going to need the protractor and a ruler. My bad, I forgot to put that on the... If you want to just pass the buckets down... on the protractor. Does everybody have one now? You can measure, when you're measuring the side lengths, just go to the nearest, like, half centimeter if you're questionable. So you're filling in this table. Alright, what was the measure of AB, the side? 10.5. Is that what everybody got? You got 10.5? Okay. This paper says 10, so I was just wondering. AC? 4.5. BC? Okay. Which angle's across from AB? So side AB, which one's across? B. This is cheating. No, you're fine. Okay. Yeah, absolutely. Bye-bye. Make myself a note. Okay, across from AC? BC? A. Okay, what was the measure of angle C? 47, 48? Okay. Angle B? And angle A? 115. Okay, what should these add up to? 180. Awesome. Okay, list your angles in order from least to greatest based off measure. What do we have? Least to greatest. BCA, do we agree? Okay, what about our side lengths in order from least to greatest? AC, AB, BC. Do we agree? Okay, so looking at the order of your angles and the order of your side lengths, what relationship do you see? So this was the smallest, so 1, 2, 3. 1, 2, 3. What relationship do you see? Okay, what matches? Very good. Okay, so the smallest side length goes with the smallest angle. The largest side length goes with the largest angle. The medium goes with the medium. Okay, so the corresponding side lengths go with the corresponding angles. So our conjecture would be the shortest side of a triangle is opposite the smallest interior angle and vice versa. Okay, so the shortest side is opposite of the shortest angle. The longest side would be opposite of the largest angle. Questions on that? Okay, so let's practice. Okay, for every problem that you have, especially when you have more than one triangle, it's really important that you label your sides. So you're going to say S for the small, M for the medium, L for the long. Okay, so you always want to start by finding your missing angles. So if you have 28, 118, what would this angle be? 34. Okay, so what's my smallest angle in my triangle? L. So what is my smallest side? I or L, whatever that is. So you're going to label that with the S, because that's the smallest side. Okay, what's my next largest angle? M. So across from M is lowercase m, so that's my medium side. 118 is my largest angle, so K is my longest side. Okay, so then it says order them from shortest to longest. Okay, so what are my measurements from shortest to longest? L, M, K. Okay, for number 2, find your missing angles first. What is angle X? 86. What is angle Z? 37. Okay, so let's focus on one triangle at a time. Okay, let's look at XWY. Which letter represents my small side? B. Medium? A. Long? Okay, now let's look at YWZ. What is my small side? Medium side? D. And long side? E. Okay, so after you've labeled, anytime there's a discrepancy, you scribble it out. Okay, because you can't be small and long. You can't be medium and short. You can't be long and medium. Okay, so unless they match, you scribble them out. Okay, so we're going to get rid of this guy. Okay, so if I were to ask you what's the largest side of this figure, what would it be? E, which is WZ. If I were to ask you what the shortest side is? B, which is XW. Okay, so if we were to put this in order from shortest to longest, okay, let's look at one side at a time. What would be my letters from shortest to longest for XWY? B what? A. And then C, what's the other one? K. If I look at WYZ, what is the order from shortest to longest? Okay, so where they share a side, you would line those up. Okay, so when I put all of these in order from shortest to longest, it would be B, A, C, D, E. B being the shortest, E being the longest. Okay, but like I said, on a skills check or something, you might just be asked what's the shortest side, or what's the longest side. Okay, so make sure you're paying attention and labeling your figures appropriately. Questions on that? Yes?
Could there be a time where, say, A is the shortest for the other figure, so it would be like CAC and then ABC or something like that, or?
There could, but I wouldn't give you one like that.
Alright.
Okay, number 1, without using a ruler, determine which line segment is the longest in this figure. Explain. Okay, so let's start with labeling our sides. So start with the top triangle. Okay, which is our smallest side? WX. Medium? WZ. Long? XZ. Okay, now let's look at this triangle. Smallest side? ZY. Medium? XZ. Long? Okay, so which one would represent the longest side? XY. Why is it not XZ? Because it's medium and long. So if there's a discrepancy, you scribble it out, because you can't be the smallest and the longest and the medium guy. Okay, so the longest side would be XY. Okay, quadrilateral KDRP is shown without using a protractor. Determine which angle is the largest in triangle KDR. So in this triangle, which angle would have to be the longest? In this triangle? D. Why angle D? Very good. Opposite of the longest side. Okay, without using protractor, determine which angle is the largest in triangle PRK. R. Why? Very good. Okay, number 4, it's kind of tricky. Compare the largest angle in triangle KDR to the largest in triangle PRK. Which angle is larger, and how would you know? Raise your hand if you think it's D. Raise your hand if you think it's R. Raise your hand if you don't have enough information to determine. I got like 5 hands total, so that's always good. Okay, so it's kind of a trick. A lot of people would say that R is probably the larger angle. Why? Because 9 is larger. However, that's not always the case. Okay, so actually you would not have enough information to conclude. Okay, because this might be, let's say, I know this isn't the case, but 60, no, let's go 120, 30, and 30. But then down here, it could be 150, 15, and 15. Does that even add up? Yeah, I think it does. Okay, so just because it's got the larger side doesn't necessarily mean it has a larger angle. And I know that, like, my angles don't add up. I was just focused on the largest angle. So just make sure that you do not jump to conclusion that, it's across from the largest angle in the figure, so it's got to be the largest side. Okay, so you cannot make that assumption. Got it? Okay. And you'll see what I'm talking about when you start your homework. Okay. Next little activity needs straws. You three are gonna have to share. We pass one back to them. You three can share. You three can share. You two. You three. You three. Oh, sorry. Okay. So looking at the next part. Inside of your baggie, you have straws, and they are different measurements. The longest one, I think, is 6 inches. Then it's 5 inches, 4, 3, 2, 1. Okay, I don't know which color's which. Just size them up against each other, and you'll see. Okay. You are determining whether you can make a triangle with the following length. So you have, for example, row 1 says 2, 3, and 4. So take the 2-inch straw, the 3-inch straw, the 4-inch straw, and see if you can form a triangle. And you just write yes, or you write no. And then complete table 2.
I don't think so.
1, 2, 3, 4.
Oh,
Okay, when you're finished, do table 2. Okay, pick a group of 3 that formed a triangle, and then add any 2 sides together. Okay, you'll add side 1 and side 2, side 2 and side 3, side 1 and side 3, and see what you get in that table. So use one of them that works. You're using either 2, 3, 4, or 3, 5, 3, 4. 1, 2, and 5?
No.
3, 5, and 6?
Yes.
2, 3, and 6? No. Okay, so it said from table 1, select a combination that did form a triangle, add any two of the side lengths together, and compare it to the third side. Okay, so I'm going to take just the first one. Okay, so I'm going to take 2 and 3, then you'll have 3 and 4, 2 and 4. So do you see how you're just making combinations with the side lengths? Okay, so when I add them together, I have 5, 7, and 6. Okay, so my missing side here would be 4. My missing side here is 2. My missing side here is 3. So is 5 less than, greater than, or equal to 4? Greater than. 7? 6? So what do you notice?
The sum of any two sides is always more than the first.
Very good. So the sum of any two sides of a triangle has to be greater than the third side in order for it to form a triangle. So two sides always have to be greater than the third in order for it to form a triangle. So notice, let's take the nose for example. You would have had 1, 2, 5, 2, 5, 1, and 1, 5, and 2. Add these together, you have 3, 7, 6. 3 is less than 5. 7 is greater than 1. 6 is greater than 2. But this right here, this right here throws it off and makes it not a triangle. Okay, so down here, the triangle inequality theorem states the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Questions about the triangle inequality theorem? Okay, so if I were to ask you, does the side lengths 7, 9, and 11 form a triangle, what approach would you take into figuring that out? Very good. So you would add two sides and see if it's greater than the third side. How many times do you have to do that for every single problem? 3 times. So you have to make sure you do all 3 combinations. Obviously, if the first one you get is wrong, then you know that it's not going to form a triangle. Okay, but you need to make sure that you test all 3 combinations. Questions? Okay. Alright, we're going to do number 2 first, and then you guys can practice on me. Okay, two sides of a triangle are 15 inches and 20 inches in length. What is the range of possible values for the third side? Okay, basically, how you get the range, x is always going to be in the middle. Okay, and you're going to make it inequality. Okay, the number on the left-hand side is going to be the difference of the two values you're given, which is what? 5. The number on the right-hand side will be the sum of the two values you are given, which is 35. Okay, that would be your answer. Okay, so these should be the easiest problems of this lesson. Okay, you subtract to get the left, you add to get the right. Okay, so look at number 4. What would the inequality be for number 4? 8 is less than x, which is less than 20. Okay, the people that get it wrong, usually forget one side of the inequality. So they might just have x is greater than 8 or x is less than 20. Okay, make sure you have both sides. It should be a sandwich. Questions on the inequality theorem? Okay. Then you guys are going to work through 1, 3, 5, 6, and 7. Okay, so it's review from everything we've done so far today. 1, 3, 5, 6, and 7, and we'll come back and regroup. Go. Alright, let's go through these so that I can hand out the homework for you guys. Okay, number 1, is it possible to create a triangle with sides 18, 12, and 6? No. Number 3, a landscape architect is designing a triangular deck. She wants to place benches in the largest corner. Which corner should she place the bench?
C.
Angle C. Number 5, list the angles of the triangle VWX in order from largest to smallest. Angle what? V. Very good. Make sure you have the angle symbol, not just letters. 6, list the sides of the triangle DEF in order from longest to shortest. DF, DE, EF. Sweet. And number 7, is it possible to construct a triangle with the given side lengths? If not, explain why not. 6, 7, 11? 3, 6, 9? 28, 34, 39? 35, 120, 125? Awesome. Any questions on the back? Okay, I'm coming around with your homework.